Welcome back. We're in 38C. We're talking about overall average rate. So we remember our formulas. Distance is equal to rate times time. And likewise, we know we can use the inverse operations here of instead of multiplication, division. And we know that rate is equal to distance divided by time, and time is equal to distance divided by rate when we just divide by one of these factors versus the other. So we're going to use those formulas in order to solve for the overall average rate. So here is our first problem, 38.7. Frank and Judy drive for 100 miles at 50 miles per hour. So their first leg of the trip, their rate is 50 miles per hour. We don't know their time, but we know their distance. Rate times time equals distance. Their distance is equal to 100 miles. And then we know on the second leg of the trip that they drive 180 miles, and that rate is 60 miles per hour. We still don't know the time, but we do have the distance. So one of the things that we can do for overall average rate is we can add these two things together and find the time, and then use that to find the average rate. So let's do that. First of all, let's find the time for each leg of the trip. So if distance equals rate times time, then 100 is equal to 50 times t. If I divide both sides by 50, then 2 is the time for the first trip, 2 hours. If I do the second leg of the trip, then I have 180 miles is equal to 60 times the amount of time they drove. If I divide both sides by 60, then I find out that the time was 3 hours. So now I have the overall average distance and the overall time, and that's going to give me the overall rate. So to find rate, we take distance and divide it by time. So rate is going to be equal to 100 plus 180 divided by 2 plus 3. So that's going to be 280 divided by 5, which is equal to 56 miles per hour. That is going to be the overall average rate of speed that gets them 280 miles down the road in 5 hours. Pretty straightforward, and you can see how all of these are used within each one of these scenarios. The only thing that we didn't really use per se was, well, no, we did. We used the time here. We divided by the rate. So we used the time is equal to distance divided by rate, and then we use rate is distance divided by time, and that helped us to find the overall average. So let's look at 38.8. We're going to throw a little wrench in this, and now we're going to try to find something else with missing information. So let's try that one. All right, so the problem starts out the same way. This is 38.8. Frank and Judy drive for 100 miles at 50 miles per hour. Then they drive 180 miles at 60 miles per hour. That's the same. We still have the first and the second leg solved. How fast must they drive the last 120 miles to have an average of 60 miles for the whole miles per hour for the whole trip? So there's that third leg, and we know that that third leg is 120 miles. We don't know the rate, and we don't know the time. All we know is that we want this average down here at the bottom to be 60 for all of these. That means we don't know the time either, because this is going to help us figure out the time for that, which will then help us figure out the speed. So first of all, let's look at our formulas. We need to find out rate. All right, how fast? That is rate. How fast must they drive the last 120 miles to get an average of 60? So the rate is what we're looking for. So we're going to say rate, the overall rate, is going to be equal to the overall distance divided by the overall time. That's what we're looking for, and we want that overall rate to be 60. We know the overall distance. It's 100 plus, actually, I'm going to save us a step, and I'm just going to add it all up down here. This is our total. 100 plus 180 plus 120 is going to equal 400 miles. So our overall distance is 400. What we don't know is the overall time. That's the mystery. So we're going to multiply everything by t. We get 60t is equal to 400. So we can take this rate that we want to have traveled the 400 miles as an average of and divide everything by 60. So when we divide 400 by 60, we get 6 2/3. Now this is the overall time that we have right here. The overall time, right? Or t to the o, whatever you want to call it. The overall time is 6 2/3. Well, we already know the time of the first leg and the time of the second leg was 5 hours. So in order to find the time of the third leg, we could subtract 5 from this overall time to get the time here. So let's do that. So we're going to say minus 5. That means that the time of the third leg is going to be 1 2/3 hours. So now that we know the time, 1 2/3, and we know the distance, we should be able to find the rate. So we're going to use this problem here, rate, because that's what we're looking for. Rate is equal to the distance of 120 divided by, and I'm not going to use 1 2/3 because that would be, I hate mixed numbers, algebra hates mixed numbers. We're going to convert that into an improper fraction. So that would be 5/3, right? So that'd be 5/3. But we really can't solve that really easily, so I'm going to multiply both sides by the denominator. That gives me 5/3 times r is equal to 120. Now I know how to solve a fraction. A variable is set equal to a whole number. I'm just going to multiply by the reciprocal. And that gives me that r is equal to 360 divided by 5. So the rate of speed is 72 miles per hour. And that's how fast we need to travel that last 120 miles in order to have an average speed of 72. So 72 would go here. Easy peasy. All right, let's see. Do we have another? We do not. That is our last practice problem for lesson 38. If you have any questions, please message me. I am more than happy to help, and I will see you in lesson 39.